We're going to divide it by E. K should be equal to about 9. So if we're going to have 25 people, we should interview 9 people and never hire them. 9. Seems like a lot. But mathematically speaking, if the people are coming in random order, that gives us the best probability of hiring the best person, number one person. Not certainty, that's not even close to certainty, that's the best probability. If we have less than that, then our probability goes down. If we have more than that, our probability goes down. This is the maximum probability. And so what I'm going to do is I'm going to show you a curve. I hope I have it on these notes because I wasn't expecting to use this particular version. But I should have some curves here. So this says basically that if you have n is equal to 20, then k is equal to 20 over e, which is roughly 7. So if 20 people, we should interview 7. We will succeed in hiring the best qualified candidate with a probability of at least. Now, how do I get this probability? That's where I get my lower limit. So I got my lower limit. Yes, Damien?
Just ask a question about how the derivative works.
Yep. I'll go through that later with you.
Okay.
Yeah. So what we're going to have here is, so we have 20 applicants, we're going to use 7. So what we have here, we will succeed in hiring the best qualified candidate with a probability of at least, and it's going to be n over e. What's n over e?
K.
That's the k value. So it's k over n, we're just plugging it in. K over n times natural log of n minus natural log of k. Now we simplify it. Okay? Now we're going to simplify it. So it's k over n, and so we're going to have here natural log of n. Natural log of n over e is the natural log of n minus the natural log of e, but you're going to add the natural log of e. And so the whole result is going to be 1 over e, which is going to be 36.8%. 36.8%. We're actually going to get this number later on in the semester again. Just remember this number, 36.8%. It's going to come up surprisingly someplace else in a completely unrelated algorithm. But interestingly enough, this has a specific value here for some strange reason. So when k is equal to 20, we will hire the best person at least 36.8% of the time. Almost 37%, roughly speaking 4%. 2 out of 5 times. Okay. And I think I have some drawings of curves here. Yes, I do. Okay, so that's good. So what I did here is I drew a lower limit curve. So the curve is basically, this is the curve right here, kn log n minus log natural log of k. And you can see, this is the curve. Why do I circle this? Because this is the derivative. So if you look at the tangent line, the tangent line, the tangent line, the tangent line, the tangent line here approaches 0, which means that this curve, which is increasing and then decreasing, is maximized in this area. And if you go down here, you can see that this is point 1, 2, 3, 4, 5, 6, 7. It looks like point 8 is slightly lower. Slightly lower. So therefore, this looks like the absolute maximum is going to be right around here, but it's very close. Once we get to 9, it's dropping off. Notice that if k is equal to 20, our probability of hiring the best person is 0. Why? Well, because they're not there. And if we interview 19 people, the probability of hiring the best person is, roughly speaking, about 5%. Why 5%? Because there's a 5% chance that out of 20 people, the best is going to be in position 20. Every position has a 5% chance. That's why it's 5%. But it's not a linear relationship. As you can see, it starts curving here. And then I think in the last slide what I have is I drew it with the maximum and the minimum if it's there. Yes. Okay. So this is basically all I'm doing here. So I'm going to make it a little bit smaller. Okay. So here's the probability of S, probability of hiring the best person, using the upper limit and using the lower limit. Okay, now there was a question, let's see if I can go back and answer your question again before I quit. So I think it was something to do with how to calculate the derivative. So I think we had that. No? I think it's going to be right here.
Yeah, just trying to understand, like,
No, I understand, yeah. I think I know what your question is going to, why you have a question, okay. So here's the function. So we're taking the derivative, so the derivative of everything in the bracket, you can think of it as this times this. So k over n multiplied by the bracket, okay? The first thing I can do is I can say, first of all, what is a constant with respect to k? No. Well, yes, but here, n, right? So k is the variable we're differentiating with respect to k. K is the changeable thing. N is a fixed parameter. 20 people, 30 people, 100 people. It's some number. We don't know what it is. It could be 100, it could be 1,000, it could be anything. So therefore, it's just a constant or a parameter. So we can take 1 over n out. See how we take the 1 over n out here? So now the derivative is really of k times log n minus log k. Let's see if I can do it on the board. I think I have space for it. Okay. So we have, I'll write the whole thing out here, e to k. And we have k over n times natural log of n minus natural log of k. Okay. So now what we can do, we can say basically this is, since we're differentiating with respect to k, this is going to be really 1 over n times d dk of k times natural log of n minus natural log of k. So we have 1 over n times the derivative of this product. Now what we can do is we can multiply this k out, and that gives me 1 over n times the d dk of k natural log of n minus k natural log of k. Now, the derivative of a difference is the difference of the derivatives of each part. So the derivative of this minus this is the derivative of this minus the derivative of that. Now, when we take the derivatives, remember, the only thing that's variable is k. So therefore, so when I finish the derivative, I'm going to end up with 1 over n. That's still staying there. 1 over n is still staying there. Now, let's take the derivative of k log n. Remember, log n is just a constant. So think of it as log n times k. Oops, that's not log n. Just think of it as log n times k. So derivative with k is going to be 1 times the coefficient times k to the 0. That's just going to be log n. Everybody got it? Why? Does that make sense? Yeah. Good. Okay. Awesome. Okay. So the next thing we're going to do is going to take the derivative with respect to k up here. Now this is the tricky one, because here both k and log k are both changing. So the derivative of a product, we're going to use the product rule. So that's going to be k times, and I'll just write ln k prime, derivative of it, plus ln k times the derivative of k. That's called the product rule. So what's the derivative of natural log of k? 1 over k. What's k times 1 over k? It's equal to 1. So this is equal to 1. Plus, what's the derivative of k? What's k prime? 1. So it's 1 times ln k, so it's going to 1 times ln k. So that's the derivative here. So we're going to have plus, minus 1 minus ln k minus 1. Now, what's ln n? Ln n is going to be some constant. Ln k is going to be constant. That's it. Is that what I got here? 1 over ln n minus ln k minus 1. Yep. Okay. So that's the derivative. Okay. Now, if we set it equal to 0, then we're going to get our maximum point. So this is the derivative is right here. Oh, I can't see it. The derivative is right here. And then we just took the resulting derivative, set it equal to 0. And we set it equal to 0, we get ln1, and that's when we start exponentiating, and then solving for k. Once we solve for k, k is n over e, which is a really nice result. Very clean. Okay, see you guys